ocean, sending waves that crash upon the sand. Hey mister, did you watch Slow Down again? There is time for you to smell the flowers, even though the thorns get in the way. Hey mister, what's your theory for today? Ooh, I've seen it, though you won't believe it. It's a miracle year in which we're living. Come on outside, it's a beautiful day.
Oh, come on outside, ladies and gentlemen, boys and girls. What you're about to see is out of this world. Step right up now, don't be shy, because we're about to show you how cars can fly.
Here's a tale of a suburban housewife who dares to fight with the icon of his day, and she finds her own miracle on the way. I said, hey now, life's a joy. You gotta try your best and give your all. And when the facts don't fit the theory, change the facts again. Ooh, I've seen it, though you won't believe it. It's a miracle year in which we're living. Come on outside, it's a beautiful day. It's a beautiful day.
5, 4, 3, 2, 1. Silence.
I'm glad I put that long intro, man. It gets me going. I love that music so much. Michael Ruggieri, my great friend, composer for my film Einstein Wrong. And if the facts don't fit the theory, change the facts. You know, it's really funny about those lyrics to that song. I said, look, I want a theme song for my movie Einstein Wrong, and I want it to be a catchy tune and it'd be an upbeat tune. And I didn't give him any of the lyrics. I couldn't believe it. He just came out of the blue and played it for me. He had known so much. I pitched so much to him about what the movie was about, what problems were in science, that he nailed it to the wall. In fact, if you haven't seen the music video, I'll have to play that once. It's sort of a tongue-in-cheek of we kidnap Stephen Hawking. So that's, if you haven't seen that, go to EinsteinWrong.com. But I am David D. Hilster, and you are here for Saturday Science Chat, and we are talking today with Jack, and he is going to be talking about symmetry math. No positives and negatives. Are you kidding me? Yes, sirree. I'm a mathematician. I got my Bachelor of Science. I don't like to say BS. It doesn't sound too good, but a Bachelor of Science in Mathematics. But today we're going to be talking with Jack, and Jack Kuykendall. There you go, Jack Kuykendall. And it is amazing stuff. I already was a fan of Peter Erickson and his Veritas numbering system or something like that. But he also was talking about the square root of -1. But today we're going to talk all about that. But before we do, of course, I want to let you know what this is all about. So talk about why we're here. First of all, we are sponsored by the John Chappell Natural Philosophy Society, all the members, and also the Dissident Science channel. We're broadcasting live to both of those today. So I want to welcome everybody from Dissident Science and also the John Chappell Natural Philosophy Society. Been having good crowds lately, growing and growing. We're getting up at 790. I guess we're getting almost 800 subscriptions for the John Chappell Natural Philosophy Society, and going up to 4,000 on mine. And I want to thank everybody subscribing. I hope you're really enjoying this. Let me take this down. What am I doing here? I don't need that thing in the middle. Come on. Goodbye. There you go. You got the logos right there. So, what are we about? Well, that's why I have these slides here to tell us a little bit. I want to first thank all of you for being here because it's really, really important for us to support people who are critical thinkers. And it's really, really important that you're here, that you subscribe. If you just here, if you're enjoying this and you haven't subscribed, come on, push the subscribe button. That's the way the world works today. Give a like on the video too. There's a lot of people watch this, and if you like this and you're not going to get anything like this anywhere on planet Earth. This is the only place you can learn about critical thinkers with new models of the universe, with new mathematical systems. My goodness gracious. I mean, where can you get that? But first of all, without all of you, this would not happen. So I want to thank you. Moving forward, what is the mission of this organization? If you're from Dissident Science, you go, what the heck is this? Well, we are an organization that above all promotes critical thinking without malice, to be an organization that supports, publishes, and promotes serious work outside mainstream science, to provide a forum for open debate about modern topics in physics, cosmology, philosophy, and mathematics. You know what it's mathematics is today. To provide a forum for presenting serious papers and theories without fear of censorship, and to be run and controlled in its entirety by its paid membership. Yes, sir. That's very important. How you can participate, you can sign up on our website on naturalphilosophy.org. Natural philosophy is, in fact, the name that was used in Newton's time and everybody else before the 20th century, when they didn't have physics or physicists or cosmology or cosmologists. Consider becoming a member. They are annual. Also, we have monthly, and participate in the community discussions on our website, and of course post news and happenings on social media. Folks, share this. It's really important to let other people know what's going on. Our websites, of course, are naturalphilosophy.org. That's a really great domain name for our group, where I really feel proud that it's our group that owns that piece of territory on the internet, because we certainly do that justice, in my opinion. Also, we have Science Woke, the magazine, online magazine for critical thinkers. So if you're not so technical and you want to read more fun and interesting information about who are the movers and shakers outside of mainstream, what are the problems with mainstream science, and a lot of great articles like, the one where the NASA scientist says, hey, gravity isn't bending light. The other way too. But we also have a Wikipedia, wiki.naturalphilosophy.org, and we have our university, which we're going to be working on this year, and have courses in natural philosophy. Of course, memberships and donations are welcome, and we have been getting memberships and donations. You just go to our website, naturalphilosophy.org, click under members and pay membership and donate, and there's a donate button. You can just donate one time, or you can be a member, and you can go to membership.philosophy.org, and that'll take you right to the page, and you can do our monthly $5. That's like $60 a year. If you don't have a big income, if you're on a fixed income, it really is important, folks. This doesn't exist without the funds. None of this stuff is for free anymore. It's all rented, basically. You pay per subscription. Some of our subscriptions are annual, some are monthly, but we do have thousands of dollars we incur to have these kinds of talks every year, every Saturday, and our conferences and our website and everything that we do. And of course, we have yearly memberships from $35 to $500, and we certainly have people who have been donating, and some of our patrons who have given us some nice money in funds and really given us donations. Dr. Cynthia Whitney, our chief scientist, who has a PhD in special relativity, but the problem is it didn't work the first time she tried to use it. That's why she's our chief scientist. And we have Nick Percival, who gave us a generous donation, so as did the other people, Duncan Shaw, an anonymous donor, which I want to thank, of course, and Robert D. Hilstner, Kurt Renshaw, and we accept everybody. We are a not-for-profit organization and registered, for sure. We are registered, and it's not a 501(c)(3). It's a different type. We decided to go with a different type when we reorganized. So, but you can deduct that, and of course, our registered members are active members. Here are some of this stuff from just chats that's happening on our website, and this guy. Herman is saying, hey, I translated a paper from Brown Effect, the experimental proof written by Valerie, I won't pronounce the last name, in 2004. It's a fundamental paper. Hey, could someone help maybe proofread it, the translation? So, hey, that's what it's for. It's a community. Person sees something they want to get out there. You can go there and post. Here's a person talking just lightly too. I see this for the benefit of all critically thinking minds. You notice that's exactly what we are. We're allowed to critically think. We're not here to tell you what to think. We're not we're not here to tell you what the truth is, but we are giving people who are seriously outside the mainstream their due and their ability to talk. So you want to join in on these conversations, just go in there. It's easy to register. So go ahead and do that. And we have YouTube members coming out. John de Clement has a video. He just came out. He does it in French and English. Ether Against General Relativity. Right up our alley. So if you want to take a look at that, it's on our community website. If you just go there and take a look at it, it will show you. I put those things in the activity feed. So whatever you do, if you're chatting somewhere in a group or whatever, all those things go to the activity feed. So you can go to our website every day and see what's happening. People post stuff. I post stuff here. If you haven't taken a look at this, it's great. I think it's Jean de Clement who actually has the world's largest database for dissidents. So I think I'm going to check that out as sometime and maybe see if I can even talk with him. I don't know how good his English is. I know a lot of stuff he's doing is translated with a voice, different voice, but I'll have to see. But he has an immense database that he keeps. Maybe one of our projects, we need to get that and take that over for him. But I'm going to click on this and it's going to probably start playing. Watch. There we go. Nope. We're going to go right to the next one. It says, oh, play What's Coming bumper. Thanks, Dave, for remind me. So I'll make sure I get this right here. February. Oh, that's weird. Where's my coming bumper? February 6th. Huh. That's not coming. That's not coming. Oh, wow. So hold on, folks. I got to see. I've got the coming February here. I've got to upload it because I uploaded one twice. It's a good thing I talked because I would have shown you the bumper ahead of time. What are bumpers and stingers and all that? These are just jargon we use for when we show these little videos and stuff that we put together. And here we go. I've got it up. And so let's take a look at what's coming here on this channel before we get to our topic today. Actually, I got to put in there Steve Bryant too, but I've got those people here anyway. So let's put a little pizzazz in there. But coming next week, we're going to be really looking forward to this, is a 50-year analysis of time in physics. Nick Percival, an absolutely great mind. If you haven't checked it out, go look up Nick Percival, the Time Guru. And you can go to his YouTube channel and check it out. I think he's got over 200 subscribers now. It's growing, but he's put up a bunch of videos there. If you really are into relativity and time and that stuff, what's going on, that's a really great channel. He's gonna be talking next week. It's gonna be great. We have coming up, Ray Galush is going to be back, and as I promised, we're going to be talking about gravity, but the electric universe's idea of what gravity is, because it's electric. I'm sure we're going to get a lot of people for that, because electric universe is quite a big crowd. And of course, coming in February also will be Dr. Alexander Unsker. He's promised to come back. Try to get him back right away, but he is a busy man. We're going to be setting up an exact time with him. And of course, Stephen Bryant, I've talked about this before. He has written a book called Disrupted, Rewriting the Rules of Physics, The Demise of Relativity. Actually, it's a review. I think you can see that review on sciencewoke.org, I believe so. Not sure. But of course, if you are working on your own ideas, just keep working on your passion. That's the idea. If you can get it organized, if you get yourself being able to write that more formally, be able to present that, of course, we have our Saturday forums open to you. If it looks like something worthwhile that a lot of people would really be interested in, we're open to having you present. But even if you don't present, as Dr. Alexander Unsker has has said to people, he says, well, I'm working on my own theory. What do I do? The idea that you're going to hope that somebody's going to come along and find your work and be discovered doesn't work so much that way. There's a lot of people who, I don't know if you've heard stories before, people who have been and worked in isolation 100 years ago, and they find their work and it's great, but it's kind of too late in some sense. So you really want to get it out there. That's just the way the world works. Doesn't matter how great it can be, but if it's hidden, no one knows. So, hopefully, think about making sure you try to get your work out there. Today, we're going to be talking, of course, about symmetry math. And I got today's bumper. So let's take a look at it. Here we go. So that's pretty cool. But who are we going to be talking to before we bring him on? He is in the green room, so he is here ahead of time. Jack Kuykendall. I guess that's the way you would pronounce it. He'll let me know. He's a physicist. I saw that. He got a degree from Georgia Tech in physics. At least that's what it says on LinkedIn, unless it's fake news. But, this fake news stuff. Problem is a lot of people call things fake news when it's really not. And vice versa. I'm not going to get into that. That's a whole different story. But he's a physicist and a mathematician, because how can you not be a mathematician if you're working on a whole new way of looking at math? So a degree from Georgia Tech in physics. He was assistant research scientist in the magnetics department. Magnetism, yeah. A lot of models now have, several models have that. Our model does too, about what magnetism it could be. Author of the Symmetry Math System, Rewriting Math, Physics, and Chemistry. It goes way beyond math. That's the thing. It seems like he was, when you're just looking at the math system, he sort of delved into other areas. And in 2005, discovered the rules of science in current math is incorrect. Let me put down some of his findings, just real quick, get it out there. Math errors in special relativity and quantum mechanics. Mass and motion, sort of, but Borcher talks about, he does mention that only mass and space exist. Mass is always in motion relative to other masses. Time allows human brains to... I'm not going to talk too much about it. I just want to give you a little bit of... and this is his video, but we're going to not do that right now. So I'm going to bring this down and remove that, and I'm going to bring up our guest today. And I was going to call you doctor, but you're not a doctor.
No, only BS. About half. And I do pronounce my last name Kuykendall, like K-I-R-K-E-Y.
That's what I like about English. You can spell it any way and pronounce it even a totally different way. Yeah, exactly. So Kuykendall. Okay, Jack Kuykendall. And you were heralding, I think, from Arizona. Is that correct?
I was initially for about 25 years. Right now, I'm living in Atlanta, Georgia, but just moved here recently.
Oh, good. Well, that's good, actually, because you're not up so darn early. So I remember when I was on the West Coast, it was 7 o'clock. But, that's the reason we do that, is to try to make sure everybody around the world can see it. Australia's got a tough time. They're at midnight, but, what can we do? So anyways, why don't you tell us a little bit? I have a very small bio of you. Why don't you tell us about yourself? One of the things I think is very curious to people, and a lot of times people don't want to talk. I just want to talk about my work, but it's really important for people to understand. There's two reasons: to understand who you are, where you come from. And it also gives them hope and says, hey, I'm sort of like this guy, you don't have to have a PhD. Today, you can learn an awful lot on the internet without having to go to college, and you can do an awful lot. So it inspires people to see where each one of us comes from. So tell us about how, who you are, what's your background, and how did you even get into this?
This is probably a very interesting one, in that when I was at Georgia Tech as an experimental research scientist doing magnetism, I had reached my brain's capacity for brute memorization and regurgitation to pass tests. And nothing was logical. Nothing they were teaching made any sense to me. And I was so frustrated, I just left academia and went into business side of the world, and spent most of my time in medical and laser physics. Invented quite a few things in the medical and business. But the biggest thing that happened was roughly 1987. I've always been a golf fanatic and discovered a superior way to play the game of golf. And so I actually changed my whole life around and changed my hobby to my living and my living to my hobby. And so for the last 30 years, I've been one of the world's top golf instructors and spent all my other time studying science on my own, using what I thought was logic. And for probably 25 years of it, still was just, I kept reading it, kept studying it, and it just still was not logical, made no sense. And finally, in the year around 2000, I came around Professor Karnarev on your site. I had joined your site, found Professor Karnarev's work, and all of a sudden it was like, damn it, 25 years worth of wasted time. This is the smartest human on the planet. He's got it right. I had it wrong. And immediately started changing things. And the math side came about in something really simple. It was something going on supposedly in the nucleus where two things are beating against each other, and because they come out zero, the actions are still there. Just the resultant is zero. And I said, well, if that's the case, a negative times a negative can't be a positive. I'll just looked it up in the math book to see the proof of it. And lo and behold, I found a math book, looked it up, and it can't be proved. They just use it because it makes answers come out right. And it was like, oh, really? So that's when it started. And it took me 5 years to do what I call breaking the dash crosscodes. This would be a future lecture if anyone is still interested. And this is how I really called BS math, Broken-Symmetry Math. And this one's fairly easy. You have a number line, which they call one side negative, one side positive. And obviously the math you do on the negative side of the line is different than the math you do on the positive side of the line. So just by definition, that's broken symmetry. And the biggest thing they came up with, obviously, is the square root of -1, a number that doesn't exist in a number system. How can anyone have a number system with numbers that don't exist? And what's interesting is you find a number that doesn't exist and you square it, it can exist. So the whole thing goes from major illogical to almost non-believable illogical. And it appears as if the male brain has the ability to say, well, we're not getting rid of this math system. We're just going to call it imaginary. So the whole imaginary system.
Yeah.
Anyway, once I broke the codes, when I say the dash cross codes, I have an entire list in the BM. When I go through broken symmetry math and all of its eras, if you put a dash out there, it has about 16 different meanings. Subtraction, negative, 1 over something. It makes virtually all the graphs asymmetrical. Everything about something called negative makes it, and dashes. And so, and there's no separation between them. Any dash can be multiplied by any dash and made into a cross, and any dash can be multiplied by a cross and made into a dash. And it's very, once you get rid of the word negative and positive, and you get rid of, and so you simply say there's directions in space. So just for example, if I ask anyone in this room that's listening, point to a negative direction in space for me. Now point to a positive direction in space for me. Hopefully you're going to say, I don't think it can point anywhere. Obviously, there's no such thing. There's just directions in space. Right. And so you make a math system where you put an arrow up, and you know the head of the arrow is the direction, and the length of the arrow is the magnitude. Now you have a magnitude and direction math system, and you only need two things: add, addition, and subtraction.
Right. Well, you know what we're going to do, I think, Jack? Won't we watch your video? Does that sound like a good way to do it?
This is
Because it,
probably a good way to kick it off, just to watch.
yeah, I think so. I think that we're getting more into that. So
Yeah.
what we're going to do right now is Jack has recorded a video. A lot of people are opting for that, and that's fine because you know it's a lot easier. You can say it a lot of times a lot more concise and make sure it's going the way you want. So what we're going to do is we're going to play a video. I believe I can't remember. It's about 15 minutes or something like that.
15 minutes,
Yeah, about 15 minutes. So we're going to take a look at that, and that will be pretty much his sort of talk for today. So let me bring him down. I will bring up this, and I believe please also tell me, folks, if I'm not too loud. I think last time I was listening to the recording, I was too loud. So I have turned this down. So let me know, thumbs up, thumbs down, if it's okay, because there was distortion. I'm trying to make sure that everybody's being heard. It's not easy doing the mic checks ahead of time sometimes. So anyways, let's take a look at this. I'm going to share my screen here, make sure the audio is being shared. I'm going to start from this current slide. And please be very, people in the room, current slide. Come on, there we go. Let me know if you guys do hear this. It hasn't started yet, but it will start. So please give me a thumbs up. I know you see there, Jack, you're there, James, Bill, those people. Once I start this, if I see your thumbs down, I will come back to it, realizing that it is not coming through the audio. So here we go. Jack Kuykendall and his talk for today on the symmetry math. Are you hearing that? No. Okay. That's what I thought. Okay. Let's, yes, I'm not hearing it either. So, not good. Alrighty. Let's see why this could be. I'm not going to share this. I'm going to unshare that. No sound. I know, guys. Thank you for letting me know. And, I will go and try to do this perhaps from a different way to do this. Okay, I'm sorry. Right now I'm trying to get this video going, so if you please bear with me. I'm going to take this all down. I'm going to go to, let's see here, bring this up. Edit all text. We're not going to even try it that way. I'm going to go to my Gmail, and we're going to get the link from Jack from him, and I will put that up there, and I must talk while I do this so people don't run away here. Symmetry math. There we go. I'm going to do this, and okay, I hear it myself, so that's got a really good chance that you probably will hear it as well. So here we go. We're going to add this to the stream, and I am going to make this larger, and let's give this a try here, folks. And please, people in the green room, give me thumbs up, thumbs down.
Math. SM is a logical math system for describing the motion of mass. The resultant of arrows is the only math needed. What SM is not. There are no negative numbers or directions in space. There are no positive numbers or directions in space. There are no imaginary numbers. There are no absolute values, and time is not part of space. In SM, all graphs are symmetrical. And the SM circle is based on 2 pi degrees. And in symmetry math, it provides both the magnitude and direction of the resultant of arrows. Symmetry math is a magnitude and direction and arrow math system. SM accurately describes the motion of masses relative to other masses and observers. A magnitude and a direction is an arrow. The magnitude is the length of the arrow. The direction is in the direction of the arrow head. All observers will see an arrow pointing in the direction of the arrow. In symmetry math, the resultant of arrows is the only math needed. The symmetry math number line is you can go in this direction or you can go in that direction. Any math operation operated on an arrow going this way stays this way. Any math operation on an arrow going that way stays that way. Definitions. MP is magnitude at a point. ML is magnitude and a length, a radius or diameter. And MD is magnitude and a direction, an arrow. Mass times distance divided by time is mass times velocity, which is kilograms per second. So M added V times or V added M times, always relative to another mass. Mass times distance divided by time is mass times velocity divided by time, which is mass times acceleration. This is kilograms meters per second square asterisk. There's no such thing as second squared. This is just useful notation. That is mass added A times or A added M times, always relative to another mass. And a mass times a distance divided by time times a distance is mass times a velocity divided by time times distance, or mass accelerated through a distance. This is kilograms meters per second squared times meters. It's mass added A times or added D times, always relative to another mass. All multiplication and division is addition and subtraction is performed by a computer. Numbers and arrows raised to powers. Powers in multiplication is addition, computer math. 2 raised to the third of arrows going this way remain this way. 2 raised to the third of arrows going that way remain that way. In both cases, there are 4 arrows with a magnitude of 2 each. 6 squared to arrow going this way is 6 and 6 and 6 and 6 and 6 and 6 and 6, which equals 36 going this way. There are 6 arrows added 6 times. The directions remain the same. 6 to the cube is the addition you see. Magnitude at a point, MP. MP has a magnitude and a location in space relative to a second mass observer. Temperature at a specific location in space is an example. A magnitude of 2799 degrees where the point 6 in the direction of the arrow and 8 in the direction of the arrow. The temperature inside an oven. A magnitude of 67 degrees points 4 in the direction of the arrow and 3 in the direction of the arrow. Temperature in a room. Magnitude and a length, ML. A radius arm or a ruler. A radius is not an arrow with a magnitude and direction. R is not an arrow. R is a magnitude only quantity. M, the mass times the angular acceleration times the radius arm times the sine of theta is equal to the length R times the mass times the angular acceleration times sine theta. The d theta is equal r theta. The arc distance is the radius times the angle theta. In degrees or radians. Degrees and radians are the same value in SM. Magnitude and direction, MD. A MD arrow has both a magnitude and a direction. It will have a magnitude number and a direction arrow relative to a second mass observer. Magnitude times velocity, mass times velocity is equal to distance divided by time relative to a second mass observer. Magnitude and acceleration is mass times acceleration, where acceleration is velocity divided by time, which is distance divided by time divided by time. A useful equation is distance divided by time squared relative to a second mass observer. Again, note there's no such thing in the motion of mass as time squared. This is just a useful notation. SM calculates both magnitude and direction for triangles. The and sign means resultant. Add all the arrows for each direction and then subtract to find the final resultant. The table is self-explanatory. The one of importance is the bottom one, where the arrows cancel out and the resultant is equal to 0. The arrows do not equal 0. They are still there. Multiplication of arrows is not allowed. Arrows are added and subtracted only. If you have an arrow of 3 and you try to multiply it times an arrow of 5, it is not equal to 15. There are two arrows. One has a magnitude of 3, one has a magnitude of 5. The maximum of these two arrows can be is 8, 3 and a 5. If you raise an arrow to an exponent, then you simply add the arrows. Addition is allowed. An arrow has a direction and a magnitude. There are no negative arrows. There are no positive arrows. There are no zero arrows. A zero would negate the definition of an arrow. Something with no magnitude and no direction cannot be the definition of an arrow that is defined as having magnitude and direction. Arrows and magnitudes are still there even if the resultant is 0. In all cases, the resultant is not the magnitude of the individual arrows. If there is a magnitude and a direction arrow, there is a magnitude and a direction arrow. A resultant is the addition and subtraction of the differences in magnitude and direction arrows. Adding and subtracting arrows by the human brain can be time-consuming when large numbers of fractions are involved. To make calculations easier for the human brain, arrows may be multiplied or divided by a number. It must be understood that the only real is addition and subtraction, computer math. Multiplication and division do not exist in nature. Multiplication and division were invented by the human brain as a useful tool for doing addition and subtraction in a shorter time frame. Whenever multiplication or division is used, it is to be understood that the number used as the multiplier or the divider does not change the direction of an arrow. In arrow math, the direction must be specified in order to get the correct answer. For example, a number with a magnitude to the right squared and another number with a magnitude and direction equals 0. From observation of this simple equation, the 3 must be in the opposite direction of the unknown number direction if the answer is to be 0. There is no multiplication of arrows. Multiplying opposite directions is illogical. In number counting math, 2 times 4 is 8 is really 2 plus 2 plus 2 plus 2 equals 8, or 4 plus 4 equals 8. In SM, when a direction is added, 8 in which direction? This has no meaning. Is it 8 to this direction or 8 to that direction? In SM, an arrow of 2 times an arrow of 9 is not equal to 18. This is incorrect. Only 2 9 arrows, which is 9 plus 9, equals 18 is correct. An arrow with a magnitude and direction of 2 and an arrow with a magnitude and direction of 9, the resultant will be 2 and 9, which is 11. You can have 2 9s, which will equal 18 here, and there are 2 9s, that is 9 plus 9 equals 18. The resultant of arrow A and B is R. R, however, does not exist. The only arrows that exist are A and B. If R is the arrow, A and B do not exist. They are just useful tools for assisting the human brain to achieve an answer it can understand. Arrows can have magnitude and direction, and rotation on axis of arrow, magnitude, direction, rotations on axis of arrow, rotation on different axes of that arrow. Using SM to solve number and direction problems, SM provides both the magnitude and direction of the resultant of arrows. Here's a graph of D equals T squared. The data is presented as shown below. the particle travels in a straight line. Starting from 0 in the center, I have drawn 8 objects moving from 0. The orientation of the arrow does not matter. All observers will see the same thing, an object moving a specified distance and direction during each second. Arrows can point in any direction. The math is still the same. Time does not move in a positive or negative direction. There is no negative time, there is no positive time. Time is a magnitude-only number that allows the human brain to observe and understand the change between physical and mental observations. The symmetry math circle is based on 2 pi. This makes radians and degrees the same number. In symmetry math, we use a 2 pi scale rather than a 360-degree scale. This makes radians and degrees the same. The resultant of a number of arrows is a single arrow which would have the same effect as all the original arrows taken together. Note, the resultant is not the individual arrows. It is just a representation of all the arrows combined. If a resultant is equal to 0, it does not mean that no arrows exist. The arrows are still there, just the resultant is 0. Graphical results of arrows. Begin with any arrow and draw the tail of each arrow to the tip of the next arrow. The resultant arrow is drawn from the tail end of the starting point to the tip of the last arrow. The resultant and sign of arrows. Add all arrows for each direction and then subtract to find the final magnitude and direction. A 6 this way and an 8 that way and a 3 that way and a 5 this way is equal to a 6 and a 5 this way and an 8 and a 3 that way, which is 11 this way and 8 that way, which equals to 0. The resultant is 0. The arrows are not. The arrows are still there. For trigonometric functions, instead of having x, y, z's, and r's, we simply have an arrow pointing in the direction it needs to go. And since virtually no one is familiar with radians and degrees being the same, I put in a conversion, an Excel conversion for transferring from BS math to symmetry math. The square of the longest arrow is equal to the addition of the squares of the other 2 sides. Greek Pythagoras given credit for magnitude-only answers. All resultant square of the longest arrow is equal to the square of the sum of the other 2 arrows is usually an approximation. Pythagoras math only provided an approximation of the magnitude. SM provides both an approximation of the magnitude and the direction. The component method for adding arrows. Each arrow is resolved into its directional components, and the resultant arrow is the addition of all the components in that given direction. Knowing the components, the magnitude of the resultant is given by the square root of the addition of all the directions. And this is a template for solving error problems. The next 9 slides will just be examples of how you can use both the graphical and the rectangular component method for solving examples. If you would like a copy of this presentation in a Word format to review, please send an email request to kuysg@aol.com. Thank you for listening.
Wow, mind blown, man. Mind blown. You blew up my mind 40 times in that. I'm just trying to hold on. It's quite amazing. This is the second math system I've seen that's tried to deal with this problem of negative and positive. And one of the things that you had mentioned to me is that you were interested in taking a look at my dad and I's book, because one of the big things we say is there are no negatives in the universe. There are none. And in your system, the moment I saw the very first page of your system sent to me, and I saw the arrows and the lines on the number line and the arrows going in different, I knew what you were doing right away. I said, this thing is going to percolate. And it is just absolutely fascinating. I have a question, a real simple question right in the beginning. How do you deal with just simple count? Like, you have 3 people and 5 people. How do you, is count, does that have a direction?
No, that's not even part of this. This is to deal motion and mass. Just a regular counting.
Oh, wait a minute. Hold on. I got to get rid of something here. Hold on. I realize that if I don't do this, hold on, I will get this weird stuff. I've learned that. Let's see, stop screen. There we go. All right. Sorry about that, folks. We were getting him. That was not your fault, Jack. I've learned the hard way. I got to get the video off. Otherwise, you were going. Say that again. So my question to you was about count.
This doesn't really have anything to do with this, a basic counting system. In other words, adding and subtracting numbers. This is all about mass and how you describe the motion of mass with equations that are logical.
I see. Okay. And then when you're saying multiplication and division are just tricks to do things a lot faster, and that's absolutely true. I mean, yes. If no one ever teaches you that in school. You just learn it. They don't tell you why. They don't tell you about the system. If a kid raises their hand and says, "What's negative? Show me a -3 oranges." The teacher will just punt, I guess, at that point.
If we get into the BS math part where I show all the problems in that, it's very easy to show Einstein's error. He has 3 dashes in the bottom part of his equation where he shows that light moves at one thing. Well, one's a subtraction operator, 2 of them are directions in space. So he multiplies the subtraction operator times the direction in space and makes it go in the positive direction in space. And then he takes another arrow pointing dash and multiplies it times positive to make it point back in the negative direction again. So he does a double subtraction to come up with nonsense.
Yeah. What's really interesting is the reason I'm even sitting here today is a man walked into my wife's store, and I had an art gallery. Even though I was had a regular job, I also am a painter and an artist. And he walked in. He says, "Look, I've got a guy. My father-in-law has found mathematical problems with special relativity, and he found a mathematical problem with special relativity. And I'm absolutely sure his name's Dr. Riccardo Carazzani. I'm not even sure if he's alive today, but he's my mentor. And he found 2 things. He found 2 mathematical problems, and then also a conceptual problem. And so I'm really going to be curious to go back to that and see what your explanation is, because I think they're going to probably match up. He just found it in a different way using the real number system. It was hard to untangle. It took him many years, because you can imagine you're trying to, like you're saying that your mathematical system is really for the real world.
It took me 5 years to break the dash cross codes. I mean, we've obviously, according to academia, this current math system is the greatest invention of the human mind, and certain other people, that the whole world is math. Reality and math doesn't exist; just math exists, and they are so far off and so wrong that it's incredible. I mean, if you think about it, the person who designed this whole math system was in 1659. There's no science even going then. There's probably 5 mathematicians in the world. And he said, "We're going to call this negative and positive." Everybody says, "Okay."
Yeah, exactly. I'm going to get some questions up here right away because I figured this is going to happen. So let's take a look at this. Says Roger Andrews says there are no negative numbers, but there are no arrow numbers in the universe either. So that was a comment. What I guess what he's saying is, oh, haha, there's no, you're saying there's no negative numbers, but of course there are no arrow numbers either in the universe. I think I know I could answer that, but maybe let you answer that.
I'm not saying there's an arrow number. I'm using an arrow as a method of showing which direction a mass is moving and the magnitude of its motion. I'm not saying that arrows exist in
Right. So what
space.
you're doing, what the arrows are, this is Roger Anderton. I know him. He's a good guy. The way I would explain it is that the system, it's a system that explains physical movements and masses in motion. And we haven't talked about that, but there's a whole implication to what you're doing. And the way I would say also is that the mathematics, the symmetry math, is really for physics. It's for the physical world. And when you look, and then
To show mass in motion versus other mass in motion, and probably two people really is it Bochart? Is the way you pronounce his name?
Bokert.
Bokert. He was one who really helped. And I actually sent him an email about 10 years ago saying how brilliant his discoveries of the fact that energy doesn't exist and the only thing that exists is mass in motion. And
Yeah.
just that very thought being thrown in, I've gotten rid of the word energy, the word force. You don't need these symbols. In other words, and you can actually use three equations to equate almost everything in nature. And that's mc squared hf e squared v and a squared e. And this is some stuff we can get into later. But photons have mass, frequency, radius, and a temperature. And Karnarev has shown that wavelength is nothing but the radius of photons. And he can describe every photon in great detail and tell you what energy level it's on and everything else. His math, this Professor Karnarev from Russia may be the most intelligent human that ever lived. His stuff is as soon as you see it, if you're a physicist, you're going to say, damn, everything I knew was wrong and this man's right.
Yeah, that is a model. We have a different model for it. I think it's just equivalent, but it is a good model. It's sort of that kind of model for the photon is very similar to what Newton was trying to do. If you looked at Newton was trying to make photons a size, and that's how you carry frequency. We do it in a different way. We just say that you can't have frequency without more than one particle, and that's in our particle model we say that. So it's not, they can be not identical, but they're very similar particles. You can get frequency. You just have lots of them, giving you a frequency. But that is a definite. I think that's a definite something for us to look at. Now, let's see. I've got some other questions here on positives and negatives. So let me go back to here. Let's see. Here we go. Here's one. It says, if you have $100 and you owe $100,000 in student loans, and if negative numbers aren't real, does that mean you don't have debt?
Again, this was your first question. How do you add and subtract numbers? This has nothing to do with adding, subtracting numbers, and the fact that accountants use debits and credits rather than negatives and positive. All you're doing is adding, subtracting numbers. This is a nonsense question when you're talking about the motion of mass.
Okay, so in other words, the question is nonsensical when we're talking about symmetry mathematics. So again, symmetry mathematics has to deal with mass in motion, and all mass is in motion. That's one of the things I certainly believe. I know Borkert subscribes to that same thing. And so you said, is it correct that you started in 2005 with coming up with a system? Is that correct?
I started in 2000. It took 5 years for me to keep going through the dashes and crosses to see how you could ever get an answer that was correct. And here's how it actually wound up being. One dash does mean to subtract. The second dash means a direction in space. So if you subtract a direction in space, it would go in the opposite direction. So if you multiply a subtraction operator times the direction in space, you can get an addition operator, or you can make it go to the positive side in space. But it doesn't just go to the positive side, it goes to double the positive side. It doesn't just subtract it to zero, it double subtracts it, so it goes all the way over to the positive side by the same amount it was on the negative side. So that's how it could actually ever even work all together, is that you have to determine which one was a direction and which one is a subtraction operator. And they're using subtraction and addition operators to multiply times each other. And why that anyone could see that as being logical, that you're going to multiply a subtraction operator times a subtraction operator and you get an addition operator. And so this is how all that break in the dash cross code did. I mean, it took years to get through that.
So once you came up with the symmetry mathematics and the arrows and the numbers, and then what you were doing, I think I'm going to try to explain a little bit too for our audience if I understand it right. What you were doing was you were looking at the mathematics that was representing physics, right? Physical things.
Right.
And when you were doing that, you were looking at the symbols and saying, what does this really mean? And it took you a long time to understand that what's really going on is that the symbols in our real mathematical system, the real number system, which is what we use, right, is when it applies to physics is being interpreted incorrectly, that the minus sign, like you were saying, the minus sign is meaning more than one thing. Is that what you found?
Oh, yeah. The minus sign has about 16 different meanings, and the plus sign has about 14.
Is that all 16?
None of them are separated. You can just multiply them back and forth across, and you multiply addition operators times subtraction operators and times directions in space, and then you use it as an exponent, and it makes graphs non-symmetrical. In symmetry math, every graph is symmetrical.
Right. And it's interesting because that's exactly what Karazani found. What he found is in the derivation of the Lorentz equations, I guess using special relativity or vice versa, I don't remember what direction, he said all of a sudden you get a V and you put them together and he's saying, look, these are not the same things. You can't just put, because you have the V and you have a V over here, you now have V squared. And he goes, no. This is not the same V. And I think, like I said, I'm going to be fascinated. I'm going to go back to his work and try to figure out, I think using your math system, it could be, in fact, he discovered the same thing, but he had to untangle it using the horrific real number system. And that was really hard for people to understand, because what happens is we have ingrained into our brains so many of the stupid rules about two negatives multiplied together as a positive, all of those rules of negative and positive, that we just use them without thought about what they actually mean.
Exactly. Now, this asymmetry graphs, for example, how could this math ever work if all the graphs are asymmetrical? And this is why no one ever found the error, because it doesn't matter if the math is the graphs are asymmetrical. If you can find data points that will fit any type of a curve going some way or another way, and the data points fit it, you can actually use that, whether it's logical or illogical.
Right. Yeah, it's again, I think what people, it's going to take some people time is for them to understand that, again, this is about mass and motion and physics. And one of the things is when you are dealing with physics, for instance, we're dealing with our particle model, and everything in the universe to us, every force again isn't real, but the forces that we see are the resulting of collisions of one mass onto another is a result of motion and mass and motion.
Is I've gotten rid of the E's and the S. If I talk about force, I say MA. I'm talking about momentum, I say MV. I never use the word momentum. I never use the word force anymore. I just put the number. It says MV. MV hits another MV. You get rid of a lot of words, and once you only have the real, which is what's going on, it makes it easier to understand it. Because once you start throwing a bunch of E's and F's together, now your brain goes confusion.
Yeah, Here's a good a statement here from Al B. Modern physics is lost in their mathematical equations. They've lost sight of reality itself. So I think you would agree with that, huh?
That one, yes.
Well, I think it's really fascinating. I think one of the this whole system could just it could just you have done that, and I think that's one of the things we really need to talk about. I think in detail. I think we're going to need a lot of sessions, but for how this mass system, it just tears apart
This
these
was
these problems we have, like space time. Why don't you talk about space time? Here's one, right? This is something that I've heard. I had in my movie Einstein Wrong. I talked with my mom. I had her talk with the GPS a guy in GPS who said, "Look, relativity doesn't work. It's not working in our GPS. Everybody says it does. It doesn't work." And then when she asked him about space time, because it goes out there in the space time, because look, space and time, those are just two. You can't put these things together. What does that even mean? Well, so I noticed that you mentioned space time. Could you maybe talk a little bit about that concept and what your symmetry math has shown about it? Meaning, here's a mathematical system of moving masses, and this is why this can't exist.
Okay. Two other people that I've studied have come up. They pretty much went along with your gravity thing from last week, which I agree with too. It's a pressure gradient. And two of them, Borg and Fernandez, have come up with what could be called the elementary particle. It's 1.86 e to the minus 9 kilograms. It is absolutely massively mass. It interacts with every mass in the universe. And this is why you get the pressure gradients no matter what the particle or mass is, like a proton, neutron, electron, etc., because this small particle interacts with all of it. And both of these people came up with that exact same number, solving nothing but the gravity equation equals the charge equation. And they've also come up, Fernandez has come up with an actual definition of charge, which is mass times the magnetic radius of the closest of the magnetic lines that can come to each other. And if you square charge and you use mr mag e to the 7th, you get the exact same number. So he has a probably definition of what charge actually is. It's a mass that is rotating, and it's the closest of the magnetic lines it created. Anyway, this is stuff like we can do and talk in the future. The rest of the math part I've done, this was just sort of a warm up to see if anyone had an interest. In the math part I've done, I've solved this hundreds and hundreds of math problems in regular physics books using this, and also the I just lost the thought I was having. The things of waves and sines and cosines. I've gotten rid of all the positive and negatives, all of those water waves,
right,
sound waves, and you can, if you move the zero from the center of it down to the bottom of it, and you just go up and down, you can get rid of every one of the negative, positive things, and all the math simply makes sense, and it's easy to go through. And I'm actually going to be making YouTube videos of all of this, posted on YouTube. And if anybody wants to see any more of this, and I would think the second one, which would be good, would actually be to go through the actually broken symmetry math and show the massive number of errors in that. And
Sure. No, I think there's a lot. Of course, there's a lot here, and I think it's going to take a long time for people to sort of grasp what's going on. In the same vein here, I'm going to get to this question or comment in a second. Just to give you an example, in our book that's coming out, we have a large section on how our model describes the physics, the forces of the physics and what's going on in electronic circuits. And of course, in electronic circuits, you have sine waves all over the place, and you have positive and negative. Well, there's nothing going on in a circuit that has any negative anything. What you have are either electricity is flowing or it's not. and it can flow, and it can do, how do you say, the amount of it changes, but again, there's no negative at all. In fact, when my father did some calculations, we never had the sign in negative territory because it doesn't make sense. I mean, there's no negative stuff even in electronics. So we're in total agreement on that, with what you're saying. Let me go back to here's one. Slope. This person's talking about slope can be positive, negative, zero, and undefined. This is per super Principia Mathematica. So what would you say about that?
Slope can be positive, negative, zero, and undefined. Why would he need to use words positive, negative, zero, undefined? Why would he just say it points this direction and bends this direction? It points that direction and bends that direction. Why does he need to put a positive, negative, zero, and undefined on it?
Well, I think what's happening is people are saying, look, I do mathematics and we use this stuff, therefore, ergo, it makes sense. But the question, I guess the question always comes back in the symmetry math is what are you trying to do physically, right? If you're just counting something, that's different. But what does the slope mean physically in the physical world? What in the physical world are you trying to describe or talk about? And I think that's where the problem goes, because showing. I mean, in electronic circuits, they use I, the square root of -1. They use it in their calculations. Doesn't mean that it reflects anything. If you ask my dad in our particle model, and you ask him what does the square root of -1 mean, he goes, it's absolutely nothing. It doesn't exist. It exists because of our system. Someone decided to make a system where I'm going to pick a place and then there's going to be a number line where will give me symbols for how big those things are. And if I go the other way, I'm going to put a minus sign in front of them. And then we use the same minus sign. And this is something a lot. We use the same minus sign for an operation, right?
Yes.
So right there you have a problem, and then when you see those things, and you try, that's where you get into kids looking at. I can imagine when you're a kid, right? You're looking at a -3 minus, and you're trying, what are you doing? And the question is, it's like the Finnish school system. They don't give you the system so much. They go play in the world, and then tell me something interesting about it, and we'll do something and try to understand it. The problem is we're now teaching a mathematical system without really any how do you say, reason why it's there, what we really use it for in engineering, and then even describe what that system means or if it's logical. We just don't get into that. We teach people rules. We then get those ingrained. And like this person says, hey, slopes can be positive, negative. Of course they can. That's using the real number system. The question is, if you are using this in a physical sense, what are you trying to describe physically? Then if you are, it doesn't make sense. There is no negative. And that's the hard part for people to extract.
Example, using this one, it has positive, negative, zero, and undefined. Let's say you had your 6 dimensions graph set up, and you've got 6 different observers at each point. Every one of them is going to see a different slope based on those type of definitions. So it depends on where the observer is sitting as to whether it's positive, negative, zero, or undefined. Where if you get rid of those nonsense words and you simply say, here's a line out here in space, and I don't care where you observe it from, it's going to look exactly like this line out here in space. Right.
And it's funny because something very similar in my film, I've got one little from a philosopher, Dr. Peter Marquardt. He's a German philosopher, really brilliant mind. And in my film, he says, look, the problem with relativity, it's a theory of observers. It's not a theory of the events itself. So this idea that observation somehow is a physical thing, mathematical thing that then relates to the physical world, that's where relativity goes wrong. And my father has said sort of the same thing because, believe it or not, we went through, 8 years of filming Einstein Wrong, and he didn't even look into Einstein if he was wrong or not. I got to the end of the film, we're at the premiere, and I said, Dad, hey, do you think Einstein's wrong? He goes, well, I haven't looked at it yet. but what happened is when he started looking at it, he actually then literally a couple years later presented a paper. He said, look, when an event happens in the universe, it happens in the universe. It's not that you measure it one way so its mass is increased. That's where you get into quantum mechanics, which is just absolutely absurd. Are you familiar with the quantum mechanics, the history eraser problems? Have you ever seen those in quantum mechanics?
No.
Well, basically what it says is that because of quantum mechanics, you can't observe where something is, and it can be in two places at once. They all come from the double slit, and they just sending one particle, and it's happening, and it knows about it from a distance. They take that logic to the extent that it says that whether or not this photon passing this star in its billion-year journey toward you goes to the left or to the right around this body in space depends on who's looking at it. And the only way you can figure out that which side it's on is to get all the conscious beings in the universe, pull them together, and it will eventually tell you which side that photon really went on. Now, this all stems from the fact because they're looking at something, applying mathematical and logical rules onto a system that are super absurd, and then they take them to absurd levels, and that really comes from this idea of observing. You have the double slit. In our book, we talk about this. You have the double slit experiment. You shoot light through two slits, and it makes a interference pattern. If you put a detector there around the slits, it just looks like there is no interference. And the idea is that observing something changes. No, what happens, you have a detector that's a physical thing. You're shooting light through it, and you can explain this in physical terms. There's nothing like that this is now an observer. But people, how do you say, they put on top of physical systems, not only mathematical systems, but bad logical systems on top of the bad math. And together you get into such a mess that you end up with things absurd, like the historic, you got to look it up, the history erasing quantum mechanics. You'll pull your hair out. Well, I don't know if you shave your head or, I would be like you, but, but again, it's this idea where we are applying mathematics incorrectly. We have symbols that don't make sense in the physical world. There are no negative numbers. So absolutely, this is truly fascinating. Let's see, zero is absence, so I regard zero can be considered reality, I suppose. Oh, here, this is, interesting. Zero is simply the absence of something, so in that regard, zero can be considered reality, I suppose. I guess he's not sure. What would you say about in the symmetry math? What's zero? Is it a result, really, or is it nothing? It just doesn't exist. It doesn't matter.
Zero doesn't exist. You're talking about mass in motion. And all I'm talking about is how they interact with each other. And so there's no such, in other words, if mass is just moving in the universe, there's nothing acting on it. It will continue until something does act on it. There's always a MV that resists change in motion acting on every mass in the universe. And so it will continue like that. There's no zeros necessary. And so until masses interact, they're just masses moving through space. Once they interact, you can say what's going on. There's no reason for a zero.
Right. Okay, I have green people in the green room. I'm not sure anybody in the green room want to come up and discuss anything. Oh, I do see somebody. So let me bring them up. Let me get rid of this here, folks. And I see Dennis's hand is up, so I'm going to bring you up, Dennis. Hello, Dennis. We're not hearing you. Check your. I see you're unmuted, so it's most likely some kind of thing there. I'm not. I'm not hearing you cough. I'm not
I think
seeing
you
you.
just got rid of COVID too.
Oh yeah, people who don't know, Jack is on. I guess on your. Are you considered
I'm
to
about
be?
the second week of having COVID, and boy, I was asymptomatic the whole time as far as feeling bad, but it's like it drains your energy, and it's just taking some time to get energy back.
Right, right. Okay, I don't know. I'm not. Okay, now unmute yourself there. Yeah, we're not hearing you, Dennis. So check on your settings. I'm going to bring you down here. Just check on your settings. Is there anybody else in the green room wants to come up and say something? I know Bill Howell was making some comments. Oh, James Keene. Okay, James. Hi. How are you? You want to unmute yourself there, James? We do have a delay sometimes, Jack. So a lot of times they'll hear us later.
Hello, hello. Can you hear me?
Yes, we can. Go ahead.
I'd like to share a screen of a little illustration I just made to ask Jack a question.
Okay.
So I'm
go
going
ahead.
to go to share screen.
So we're sharing a screen here. I guess James has, man, drawn you something up. I mean, people are,
Share
you got
screen.
people so excited, they're drawing pictures for you. It's going to be a stick man, yelling at you or something. I don't know.
Can you see my graphic?
No, we can't see anything
Can
right
you see
now.
my graphic?
No, we can't see anything.
We're seeing just your beautiful face.
That's it.
Oh, I
You do have a share. I do know you do. If you're in the
your
green room.
entire. I have to click.
Okay.
darn
That's
it.
all right. It's okay. Okay, no, I do see a James Keene, but it's coming on as
Do
a
you see the
second
graphic
person.
now?
No, but it's actually coming in as a second screen. So let me go ahead and add that here. Go ahead. Yeah.
Oh,
got it.
okay. I made up a little character called Mr. Wall Street Bits as a play on the popular Wall Street bets that's been in the news in terms of the stock market so far. I think that with just 3 math ideas, you can build a computer and a fully functional universe. 0 or 1, a 1-digit binary number, and logic, and I give the truth table, not logic with the truth table. You don't need math based on continuous space-time theory, which apparently symmetry math accepts all in, using real numbers for every point in space and time, which is popular in failed standard model formulations, which at best can only approximate physical events and which look like this. I just pulled an equation out of the formulations for math formulations in the standard model, which is a bunch of gobbledygook. So the question for Jack is, has he considered full quantization of space, time, and energy, where only these 3 simple math ideas, 0, 1, and logic and not logic, are required? End of question. Thank you.
Obviously, the answer would be no. I haven't considered anything like this. This is what I've developed at this mathematics that describe exactly what happens when mass interacts with other mass, and it gives answers that agree with the experiments. So basically what I'm going to use is Feynman's. If you have an experiment and you have math that can agree with that experiment, then you can continue on to say at least you can use that. To say that I've looked into computers and how they can control the universe, no, I have not looked into something like that.
Okay.
Well, how does what math theorem in algebra, vector and trigonometry, does your symmetry math actually disprove? Because it seems like you're relabeling math symbols, which does not really change the underlying math. Like what David said a while ago, -3 oranges just means the direction that the 3 are moving.
Okay.
So you put a minus, somebody else, somebody call that a -3 oranges. Somebody else might call it the direction of the oranges, but it's the same math.
All right, let's do. No, it's not the same math, not even remotely the same math. But the traditional math line used by BS math has a negative side and a positive side. The math you do on the negative side is totally different than the math you do on the positive side. Therefore, you can't even make that statement you just made. It's broken symmetry, and you can't use the left side and the right side being the same thing. They're totally different in BS math.
Right. So what you're saying, I think what you're saying, Jack, is when you look at, for instance,
is there a proof?
What?
Is there a proof or a disproof which you presented of any mathematical theorem at all?
Yes,
even one.
Almost every one of them, yes. That would be a second lecture where I go through all the arrows in BS math. This was just the first one to introduce you to a math system that's logical and works. And now I can go back through math systems that aren't logical and don't work in another lecture, which is BS math. There's so many arrows in BS math that it's going to take 2 or 3 lectures to even remotely start going through.
Yeah, no, I think it's worth it. What he's saying, what you're saying is that when you apply, what happens is the real number system that people are using in physics, and even in engineering, a lot of times, those things when you're trying to, especially when you're dealing with more theoretical physics, when you're talking about relativity or quantum mechanics, is that the symbology is bad. You have a symbology of a minus sign that you said that has many different meanings. And if you look at, like you said, if you look at this in real number system, if you look at the right side and the left side of a number line and the operations that go there, like the minus sign, for instance, you have a mix-up of what's going on, and that mix-up gets translated into using a mathematical rules of a system that's fragile when it comes to representing the real physical world, and those problems in that the real number math system, when applied to real physics problems, ends up falling apart. And if you look at the universe as moving mass, like myself and Borkert and many other people do, then what you find is that the symbology of the mathematics that's being used, and people say this is totally fine, and when you would translate that to the physical world, it isn't totally fine. It doesn't make sense. And like I said, Dr. Karzani, I've seen him spend 4 years doing it in the real math world, and it's really hard to do that way. So what I think we will do, Jack, is we've got to come back, and for, again, those here BS math, what that really means is the broken symmetry math, meaning math that's being applied to moving objects in the physical world and how that falls apart because of the system itself having ambiguities, meaning, you have a symbol that looks the same, you treat it the same, you have symbols that look the same, like 2 V's, in an equation that are very different. You put them together and you square them. That's what Karzani found. He said in special relativity, you're in Lorentz, you've got this V and you got these V's. These V's are not the same. You're putting them together, squaring them, then doing a mathematical operation on it. You've already lost because you've done something in mathematics symbology in a system that doesn't recognize the difference between what these things really are doing. And that's, I think, what you came up with, right, Jack, is a system that says, okay, we can no longer just use this system because it's ambiguous. It's causing us problems. It's not only causing us problems, it's giving us things like relativity and us saying that the mathematics behind that is okay. So
there's one simple thing I can do. There's 2 very simple little equations that other people have sent to me and put out to me that wanted to know if I could answer it for them, because if you use the rules of BS math, you always come out with 2 equals 1, or you have to say that something is zero. There's no way to get around it if you use the rules of traditional math. And so what I will do, I'm going to send you a little tickler of these two equations and see if anybody wants to try and solve them before we do the BS math thing to show you how easy they are to solve if you use symmetry math.
Yeah, no, I think that would be totally fascinating. Well, listen, I thank you very much, James. I really appreciate your input. I mean, it's really great to have people on here. I think this is, yeah, I mean, this is a good statement. Our mathematical system, our real number system, with all it's got a lot of flaws. It's leading us to incorrect conclusions about reality. I think that puts it in a nutshell. I think you agree with that, right?
I agree with that 100%. Yes.
Yeah. Okay. Well, you got Al B is either is buying this or he's drinking the Kool-Aid or whatever. But no, this is just absolutely great. I'm sorry, I'm a math nerd. I mean, I got my Bachelor of Science in math, and it's so funny because my father, who is an electrical engineer, and of course he has to know a lot of math. When we started developing the particle model that we have, which is the whole universe is just moving mass. There's nothing else. There's nothing else. There's no negatives, positives. There's no charge. None of that. If the idea of putting a positive, negative charge in the universe is just a way of saying a direction, right? That you have here's an electron, here's a positron, and they're going to come together. Well, what's pushing them together? It just doesn't move by magic. But I was thinking, well, we got this particle model that just brings it down to mass and movement. And he is just completely fascinated. In our book, we explain what's really physically probably going on in the physical components of electronic circuits, which you never get told about. If you go to physics class, right, Physics 101, and you raise your hands, what's current I mean, we're talking about electronics, one of the most important technological advances in human history. Maybe it is the most important. Well, they say, current is the holes left behind moving in the opposite direction of electrons moving in the opposite direction of current.
Just to let you know, Kerner answers all of those with his theories on that, and actually shows what goes on with diodes. And he just says, it's this thing holds and stuff. And he actually explained what goes on. That's something future. There's one other thing on the motion of mass. There's a person called Ripsick on my list of authors that I've listened to, and he had one of the most profound things that started the whole thing off that helped. And he made the statement, says, suppose there was just one particle, one thing of mass in the universe. What could you tell about it? Absolutely nothing. You could be moving at 100 times the speed of light.
Yeah, exactly. Yeah.
And still, that's nothing to measure it against. He says, now bring in a second particle. Now what can you do? You can say what they're doing relative to each other. That's all you can say about them. You don't know which one's moving. You don't know which one's sitting still. You don't know if they're both moving, coming together, coming apart. And now you throw in everything in the universe, and that alone tells you why Einstein's stuff is nonsense, because you can't bend something and everything else in the universe change.
Yeah.
So
no, it's crazy. I think, like I said, I'm going to be really fascinated to see how the explanation, I mean, applying symmetry math to special relativity, if that comes to the same conclusions as Dr. Karazani came to, because it came to the exact same problem. I mean, and people didn't understand it. And I think part of the problem of people not understanding what Karazani found of the problems in special relativity, which I think you found the same thing, but you use a system that shows it very clearly, is that he had to work in the real number system to try to find out what you were finding out, right? And that's really hard. That's really hard.
Science is if someone comes up with an idea, he probably isn't the only person who came up with that idea.
Sure, absolutely. Yeah.
You can find somewhere someone else has written something about it, and you're going to say, and someone's going to let, well, this guy wrote, like you just said, what's his name? Karazani,
Dr. Karazani.
Someone who perhaps has already rewritten everything I've done, just in a different language.
Yeah, well, I don't think he has. He's discovered the same thing. And I think there's a lot of people, I've seen it, discover the same things from different points of view. I think one of the things is, if you look at what happens, relativity falls apart when one thing happens. when you take a look at what it's truly saying about the universe. If you don't look at the math, if you are the person that sits in class and you're taught the real number system, you know that inside and out, you're given the derivations, for instance, Lorentz equations using relativity, therefore there's no ether, that kind of thing, you see that math. You can go through and step by step and reproduce it and regurgitate that. But if you step back, like tens of thousands of people have, and I know tens of thousands of people have, and take a look at what relativity is actually trying to say with its postulates, what Einstein was really trying to say, you really quickly see that when you look at the physicality of what he says and his assumptions, for instance, if the speed of light's constant for all observers, which of course is you're thinking to yourself, that doesn't make sense right away. It just doesn't make sense. And then he goes on and says a second postulate that all things in inertial frames, all the physics is the same. He just contradicted himself big time. If everybody who I've known who really honestly, and I mean honestly, not tried to say, well, I'm going to try to find a problem. No, honestly step back and try to say, what is the physicality of what relativity is saying? It falls apart so quickly. And the same thing with quantum mechanics. When you start to see what they're saying and what they're saying as their basic postulates, and you try to translate the physics. What's good, though, is that what you have done is you've now given the world a mathematical system that now you can go back to the real math, look at what they're claiming to do, and say, okay, where does it fall apart? Now, obviously, you have done that, and that's what we're going to talk about in future. Believe me, I don't care if no one comes but me and Al B. No, I'm sure there'll be more people. But we do need to now see that, because this system could actually be the death knell of what we have been trying to show, what Karazani has been trying to show. The problem of Karazani, let's look at it that way, Jack. Karazani probably I'm absolutely sure because I studied his work for a decade. And what he came up was that you have V's that are different. You can't put together. You have an exponent, a minus sign that doesn't make sense here, because he's saying minus 2/3 versus a minus 1/3. He says, if you follow what you're supposed to be doing, your derivation goes wrong right here. But what happened is how can he show it? Well, people would just say, well, you're saying that, but that's your interpretation of that. And that's where it goes wrong. Because what we both know, Jack, is that the real number system and the symbols used and the rules used are just a mess. They're ambiguous. They mean two things. They mean it's something here different. And I think what happens is now, if you recognize, okay, if you have the symmetry math system, and that really describes unambiguously the physical world of moving masses, and now let's apply that to quantum mechanics, relativity, and all the other things, you can very clearly show how that falls apart, and that the problem comes in the math. Here's a general question to you, and this is going to be good for the next session, which we'll probably maybe have more than one, is that when you applied your mathematical system to these other problems, what did you find? What were you finding? Is it just such a mess, or can you basically nail down right here is where it goes wrong? Did you come to a specific conclusion, or was it really just misapplication in a confusing system across the board? And this is a higher level question. Not a specific question to relativity or specific question. What did you find as you were being the first person to apply symmetry math to these problems and find out the broken symmetry? What general conclusions could you make at a higher level, getting us interested for looking at the details in coming sessions?
Okay, that's really it's almost like I led you to that question.
Well, at least I asked it, hey, give me hats off,
I'm going to have to now go back to Professor Karnarev. As soon as I started studying his work, he everything he has all of his stuff's on the internet. He has several million followers. He may not even be alive today. He was in his late 80s the last time I emailed with him. He has a complete system of showing that quantum mechanics isn't even necessary. You can explain everything
Oh yeah.
with standard.
Sure.
With standard, you don't need quantum.
Newtonian physics is what we call. I agree with that 100%.
And so the everything he did was a computer translation from Russian into a computer in English. And I've been studying him now for 15 years, translating
Right.
because in Russian, when I first started, it was like, I knew nothing about Russian, and they make a whole big long sentence, and then right at the end they say not. You say, oh,
Right. The negation goes at the end. Yeah, it's confusing.
And it's taken me years to work my way through it, change his symbols into simpler symbols where they're understandable. And using his work, I've totally rewritten something called thermodynamics. I'm simply calling it heat based on his work. I've gotten rid of the first and second laws of thermodynamics and entropy. You don't need them at all. You can use one simple equation. What is the temperature now? How many photons were absorbed? How many photons were emitted? And you have all of what's called thermodynamics. You can call it heat, and you can literally get rid of almost everything in thermodynamics with this simple heat thing that he explains so simply it's hard to argue with. He does go through all of your electronics of how the electronics actually works, not what the electrical engineers and all those equations go through. But he goes through a real definition of photons, electrons, protons, neutrons. He has operating models. He shows how they all combine together correctly. He shows how water is not even remotely the way put together the way chemistry books put it together. And so basically all I've done is spend 15 years translating his work into something that's understandable. And I will be posting all of that onto YouTube over the next year.
Okay, that's great. The other thing too is I think we need to do with you is to get you in our university to teach the symmetry mathematics and also even the failure of the broken symmetry mathematics. We have online system that's very easy to use. It's a professional teaching. It's like, the online universities now.
Right.
Yeah, it's hard for you to go to university in mathematics departments. Hey, here I am. I'm going to teach a course. Oh, that's fine, Jack. We're going to have you teach a course in symmetry mathematics. Unfortunately, it's not happening, but we do have that ability to do that. But yeah, I think we need to do that. There needs to be a book. Are you planning to write a book on this?
I have found that I've actually had a website with all of this on it one time, and then just closed it down. I'm not sure whether I want to. That's actually way too much for a book. I mean, I've got hundreds and hundreds of articles. That each one of them in itself is a book. So I think probably the easiest way is just to put it on the internet, and I would love to put it on this site in some fashion.
Yeah, no, absolutely. What we're going to do is we need to get you on Science Woke as one of the critical people in mathematics, especially. We've only had Peter Erickson up till now with his veritable number system, and there's a lot of great work. He does a lot of great work, especially on infinitesimals and infinity. But he's come up to some of the same conclusions. I think your numbering system, though, has for physics and the way you've done this is going to, how do you say, is a cleaner system, especially for when it comes to physics and engineering.
It is something that anyone who takes just a little bit of time can literally solve anything in any general physics book with.
Right, right.
Is it all right if I be just slightly egotistical here?
Of course, believe me.
I don't know if it helps or doesn't help, but I've had what I don't know if you call it problems or not, but I've been able to see things in the world quicker and cleaner than a lot of other people have. So when I was in my late 40s, I took a Mensa test just to see what my IQ was, and it winds up I'm 184. I'm like 20 points higher than Einstein. So I can see things and be able to, and because I spent the last 30 years teaching people to play golf easier, I can translate it down to something that people can understand. I'm getting
Right. No, I understand.
all,
Yeah.
all the, like you, all of the words that don't mean anything that you brute memorize that don't mean anything.
Right, right. Yeah. I spent my last 30 years looking at words and what they mean, so I'm very cognizant of that. You know, I know a lot of people who have taken IQ tests. I have taken myself. It's, you know, the people I know who I really enjoy talking to usually score pretty high on those. And the people I've known are ranges from 160s, 180s, and even higher. And I think what that really means, in my opinion, in the end, is that you have the ability to really let yourself try to find the truth. I think the problem is people will always find their biases, even in mathematics, and they're just, they don't have this ability. I don't know. I think people I know who are really brilliant, who come up with really amazing ideas, is that the way I would describe it is you have this childlike fascination with the universe. If you take a child at a very early age, they don't go up to something that everyone, oh, that's a bad thing. They'll see mud and jump right in and slosh around in it, and they'll go, oh, this is really fun. Why am I not supposed to be in this? Or, they'll look at, or they'll go up to a person who's like literally crazy. Maybe, they're not, they have some problems with their brain. They don't function well in society, and they'll go up to them and think it's curious, and they'll look at it. There's that curiosity that just allows you to look at anything. What Aristotle said, how do you say, a mark of an educated mind is someone who can question or look at anything, even if they don't believe it. And I think that's the thing. I'm a person like that. I will look at everything. My dad and I have a model of the universe. It falls in line exactly what you're saying. You had asked me for maybe a look at the book, but we're going to have it. I will gladly have you be a pre-reading of it. But it's really amazing to me how these people I know have the ability to entertain something. They look at something. When you said you had a new math system, I didn't go into that. Oh, right. There are two different types of people, right? They're going to go, all right. Okay, what's this guy? Like, he solved it, I don't know what that is. And to me, it's like, oh, that's cool. What did you? And then when I saw the very first number line, I knew what you're doing. Absolutely. I said, my goodness. And then I saw all the things that you were doing, and now I know that it's all applying to mass and motion. This basically is your number system, in my opinion, should be the one we use for all of physics. That's it. Because everything is mass and motion. Of course, you have to believe that as well. So, I'm not surprised because, like I said, Nick Percival, who's coming on next week, I'm sure he's been watching. He's actually been sending me emails during this time. He's a brain up there. I'm sure his IQ is way up there too. But I think what's fascinating to me about those people like yourself and being around brilliant people is that you have that childlike attitude.
Yeah, David, after that promotion, checks in the mail.
Yeah. Oh, that's good. Checks. Hey, we need donations for go to our site and donate to it. But truly, I literally, I do know people. I happen to work in the supercomputing department, and I know some brilliant minds. But if you look at them, they are ones that are the ones who are, it's not that they're least certain. It's that they're always open to looking at something. They never look at even what they do as the end all be all. But it's just an attitude toward life of, oh, that's really interesting. Let me look at it, and really taking a look at it. And there's not too many people like that. I sort of look at the human race as being on this planet of water, and everybody's underwater. And the further underwater they are the least critical thinking, the least looking at the universe and trying to learn. And once in a while you pop up and you see other people who are up there and going, oh, hey, hi, Jack, how you doing? And you're looking at the universe with this wonderment, really, and that you really work on that and try to find what that is. You don't let your biases or biases of the systems that you've seen get in your way of trying to find what you're going at. And it's really amazing because I think one of the amazing things about your journey, and I want to get that story on Science Woke, is we have a part on Science Woke magazine that talks about your aha moment, right? My dad, he, in my opinion, solved the wave-particle duality. It was in 2015. And when he did, I went nuts, and he didn't even know he had done that. And in my opinion, again, this is my opinion, but when you have those aha moments, what brought you there? Because you told me a very telling thing, and I know this because I've met people who've come up with brilliant solutions to things. It doesn't come to you overnight. You come up with something, but it's a huge journey. I mean, you said it went, 5 years? All those things that you flashed on the screen, I'm looking at that and go, and during your talk, I go, give me a break, Jack. I need to look at that screen for at least 2 days. What, you just put it up there, then you put another one up there. And I'm thinking to myself, Jack, this is torture. I have to admonish you because I wanted to stay on that. I almost froze it. I almost did, Jack. I was there with my mouse and I was going to freeze it because of, just looking at the graphs, the symmetry graphs. So I think it's really, it's not surprising to me, but I think we need to get your story out there. Let's work on that. We need to come back. I have other people in the room here, the green room. I have Bob Gray. He rose his hand, so I don't keep on. I love math, but I'm having a great time here. So for those of you who have not seen it, I did put below there P.M. Karnarev, Russian scientist, theories in physics, chemistry, for those people who want to look him up. I'm going to bring up another person, Bob Gray, who had raised his hand. Hello, Bob. How are you?
Hello. Thanks very much. Hi, Jack. Have you ever read R. Buckminster Fuller, and in particular his book Synergetics, The Geometry of Thinking? The reason why I bring it up, I'd like to bring it to your attention because he is another brilliant person who has looked at math and tried to develop a math system, an approach to math that's much more rational and fits with reality, if you will. And if you're not familiar with it, I recommend it. He's not doing number lines like you are in particular, but it's another approach to the way he looks at universe and things in universe and where the math kind of fails and what doesn't make sense and his attempt to make sense of it all.
I have not read it, but I would, again, I'll be more than glad to take a look at something like that because I'd like to see I'm pretty much like David. I like to see what anyone else is saying. And one of the things that I do as well is I'm extremely slow. When I say that, the first time I hear something or see something, I take days and days to mash it around, and it may be 2 months later I can say, that's why. I don't, like I was asked a bunch of questions early on about counting numbers, and it's like they missed the whole point of this. And so I don't really hardly ever just answer a question when I'm given. I'd say, okay, I'm going to write this down. I'll get back to you in about a month.
Yeah. The reason, one example out of Fuller's Synergetics that I particularly like is he asks the question, when God wants to make a bubble, right? You have a boat, it's going by, it's making all these bubbles on it. To what decimal position does God truncate the number pi? Because the way that we calculate spheres for this beautiful bubbles is with the number pi. Right. But that's an irrational number. It just doesn't make sense. So he concludes that God must not be using pi. So there's got to be another mathematical system that doesn't have these irrational numbers and yet accurately describes what's going on in universe.
I spent quite a bit of time thinking on that one, and I've come up with nothing yet, because one of the things that, let's say you take a circle where you're getting the circumference. If you had a string and you cut that string and you laid it out, and you had a good enough measuring device, a scanning a tumbling electron microscope, you could go out an awful lot of digits and give an exact number of the length of that thing, and it could be a number. It wouldn't be irrational. And so That's incredibly interesting. Is why we have to have an irrational number to get something as simple as the circumference of a circle.
Yeah. Yep. So as I say, Fuller explores those kind of things as well, and I think you may enjoy his book. Thank you for presenting today.
My pleasure. Thank you.
No, I think that's what that is amazing. It's funny because my dad is the same way. I'm a little opposite of you. My dad is much more like you. When he presented me his model for light, because he was looking at light through sort of what people in etherists were looking at, and he says, "Can I get waves from a particle?" And of course, with one particle, you have to make the particles different. But how could I get a wave from, light waves from, the same particle? And he came up with a solution. And that's, it's actually on my shirt here for our book. I told him, I said, "Dad, this is a solution for the wave particle theory." And he goes, "No, it's not." And then like 3 weeks later, he literally knocks on my door. He goes, "Dave, this is a solution to wave particle duality." And so, it really depends on each person. I'm one of those people that collect a lot of things. And when I see it makes sense because I've sort of prepared the ground. And when I saw what I've read, Peter Erickson, I've been a fertile ground for saying this numbering system we use is a mess. And I knew Karazani, who was working right with, that's what he spent 4 years of a brilliant life. He's just a brilliant guy, spending his life working in this real terrible number system to try to untangle where special relativity went wrong. And he found it. Then when I come across and I see your stuff, and literally in 30 seconds, when you send it to me, I said, my jaw dropped open. But it's a different way. I just think different people go through, different things. One of the things I would say is I think this number system is fantastic, and in my opinion should be used in all of physics right now. I just don't see why you would do different, because if you do different, you end up with wrong answers. That's what happens, right?
Yes.
So I would go on a limb and say that, but and you should also get used to, you're going to get, this is one thing I've learned because I've been around this long enough and know so many brilliant people like James Maxwell and expansion tectonics, people like that. Yonel Deneau showing the underwater experiments, showing how magnetism probably works physically, all these people, but you have to get used to getting questions, and you're going to spend time, but they'll be worth answering, because if you answer those, that gives a person another step to where they're going to come to a better place, right? Once you understand how to answer the question, well, what about counting, things like that. And it's not part of the system because it's not talking about moving mass. That's not what you're talking about. But when you're talking about physics, and the question here, I got another question for you. Here it is. Do we need two math systems? Or do we need a part of the real number system, throw most of it away, and then the rest of the new number system will be a small part of the real number system, and then the symmetry mathematics? Is that what you think is going to happen?
Can't answer that one.
Come on, Jack. Put your neck out on the line.
What I'm going to say right now is we just got a conversation started.
Right.
It appears like it's going to be a good conversation. And what you're seeing now is the work of one person translating the work of about 5 or 6 other people.
That's normal, yeah.
My interpretation into it.
Yes.
Once I find that something useful is presented, and other people start, like what you said, this just makes sense. If you don't come up with ways to make this better, it will surprise me.
Right.
And so I'm open to anybody who wants to start, a group of, let's build the greatest math system ever used for motion in mass. And, I'll be one of the members. I don't have to be the guiding member of it. We can use my model as something to start with, but what we would need to come up with is how we describe the motion of mass and how it interacts with each other. And The other thing is too, the math I'm doing is incredibly simple. And so anyone, like you were in software, we need a software program where you can just plug these numbers in and all, when you're solving a problem, the answers just popped out.
Mm-hmm.
But I'm not a software writer, but I take an Excel and, screw it around with, nors and knots and come up with something where I can make it work. But we need a computer system that can actually be sold as a calculator and make money for buying a calculator.
Well, I think we need to see what it is. In my opinion, just looking at your stuff and having looked at this problem before I knew about what you came up with, symmetry mathematics, absolutely there's problems. Peter Erickson showed many of the problems in the real number system. The way I look at it, what we're going to end up doing probably is to throw out parts of the real number system the way we're doing it. I mean, it just doesn't make sense, especially with the minus sign. I mean, it's got too many problems. And what will end up happening is we'll have the real number system meshed with, a symmetry math. If you're doing, the physics of what you're doing, it depends on what you apply it to. And I think that, I don't know, will one system come out of that? I mean, that's going to be the $64,000 question. Are we going to have one new math system? Is it going to be the symmetry math put together with parts of the real number system that we use to end up with a new math system that someone will see some overall arching, vision of what that is and relabel it, right? I mean, just relabel that system. But I think that's where we're heading. I don't think the real number system days are numbered. And I dealing with a young, my daughter's 15, dealing with the mathematics that she has and the new math that they do and the way they do it. I mean, I think a lot of the new math of trying to make how students somehow come up with a system that's easier than this arbitrariness and the ambiguity of a minus sign, for instance. I think it's going to change. I think we're just going to have some type of putting together of those two, in my opinion. But okay, anybody else in the green room? We have 6 minutes left. Anybody want to come up? Wave your hand. But I'm certain that we're going to have to get more information about this. What we need to do, Jack, is to get working on your profile in the Science Woke, get your background, get it in there, list what you're doing, so that people know about it. We need to start I know you're wanting to do YouTube. I know you have a domain name, symmetrymath.com. I think that's yours, right?
I may still have that. I'm not sure. That's where I had.
Well, I can look that up and who is it?
I might be that up by now. I'm not sure.
Yeah, but I don't know. Do we have a group on our website? A group for symmetry math? We should probably have that. I'm looking it up right now. Groups. No, I don't think we have a group for symmetry math. Let me look on the groups page. We should probably put that in there. So I see binary mechanics, ether consciousness courses. So you have marketing. Nope, we need to make one. So what we need to start doing, folks, I think what we're going to do is start organizing. I will certainly help with that. Get ourselves a group where we can start discussing this on our website on naturalphilosophy.org. And we need to get Jack's information up. And I think there's a lot of people who are interested, so we're going to have to find out a way to disseminate this information. And you have a YouTube channel as well, and get yourself organized into the real world of social media. So, and also tell me about golf. You are still, since we're rounding up here, coming up to the end here. So are you playing golf still? You're in Georgia now. Do you go to Augusta?
Yes, I'll definitely play. I'm still about to launch a big program of inventions I've done. If anybody's interested, it's called kggolf.net. kggolf.net.
Okay, kggolf.net. I can put that up there. kggolf.net.
So if you want to play
Okay.
the best golf in your life in 30 days or less and get rid of all the motion you're doing, I can show you how to do it.
But it's expensive. Are you a rich man from all this, or are you just you're doing okay?
I'm just doing okay.
Okay. We're always looking for people to help back us, right? Donors.
We're fighting you're fighting PGA, and so you're fighting tour golf.
Oh yeah, that's true.
So same thing.
You're fighting big science, and you're also fighting big golf. That's not an easy task. So okay,
Right.
I was just see if I could hit you up for a big donation to our cause here. So that's all. But anyways, so I want to thank you very much. We're going to stop here. We'll absolutely have you back. And I think what we need to do is we're just going to have a lot more sessions. I think we need to put up a group on our website. So those people who are interested in this, who want to learn more about it, we need to get your information out there in a place where everybody can see it. We have a lot of different ways to do that, and maybe we can have some people help out with that as well. But it's been really fascinating. I think a lot of people here have really, I can see from the chat that people have been very engaged with this idea. I certainly am. And I think, in my opinion, if I were to look at what this could be, this really could be a mathematical system that we all agree upon works very well, is unambiguous, and can show one of the biggest things it can do is to really shoot down a lot of the mathematics to physics theories that we all know are problematic, but doing it in a mathematical way. Yeah, it's a new system, but doing it in a way that you can't dispute it, because it's going to be, in the end, I think one of the things is like our model breaks the entire universe down infinitely up and infinitely down into moving mass. Your mathematics breaks down, does the same thing, gives a mathematics to that. And the moment you try to apply it to something in a theory that's wrong, what you're really finding is not that the mathematics of the real number system's wrong. It may have gotten you to a wrong conclusion, but when you then look and apply your mathematical system to it, you realize that the physics of what they're trying to do is wrong, right?
Correct.
So that's it. Well, thank you so much, and we'll have you back. Thank you very much for coming on. We really appreciate it.
Thanks, David.
Okay, so that was Jack, and I'll tell you, folks, that is just absolutely fascinating. I hope you really enjoyed that. We're going to have him back next week. We're going to be having coming. I'll put those on again. I'll put that out there. So here's what's coming on our future episode. Yeah, I am your host, and it is 11:59. It's almost noontime here in Florida. And if you are interested, again, you can join our group. We are Natural Philosophy. You can subscribe to us. We are on Natural Philosophy, YouTube, naturalphilosophy.org, or YouTube, dissidentscience.com. And that will get you to our YouTube channels where you can subscribe and be alerted to when we have these Saturday morning chats. We are filling up. It's great to see months ahead of time, so we're already into March. So again, if you have something you think that critical thinkers should know about and want to present here, get in contact with me, and we can see if that's something that'd be interesting to our group and people. So we're going to give you one more video before we go on out. Remember what I always say, stay critical, stay thinking. I am David D. Hilster. I am your science therapist trying to get to the promised land of becoming a critical thinker. No, we're not here to tell you the truth. We want you to find it out yourself. Ciao for now.